let's look at this problem. It's from AOPS, Introduction to Number Theory. What is the largest 4-digit palindrome that is the sum of two different 3-digit palindromes? I've went ahead and written down this equation here. This is the first palindrome, this is the second palindrome. Now the sum should be less than 2,000 if it's 4-digit because the largest we can get is 999 plus 999, and that's still less than 2,000. So if it's a 4-digit number, it should be 1,000 something. Now the reason the units digit is 1 because this is a 4-digit palindrome. The last and first digit have to be equal, and the middle two digits are equal, so they're both E. So let's just start. Now we can work with this. So we know that A plus C is equal to 1. Or the second case is that A plus C equals 11. Now, it looks like the first case makes more sense, but no, we have to prove this. So we figured that the first case actually doesn't work because if A plus C is 1, then one of the digits is 0. If A is 0, we have 0, B is 0, so we only have a 2-digit number, which, well, doesn't really work. So we only have a 2-digit number, so that doesn't really work because we have 3-digit palindromes needed. So A plus C is equal to 11 then. This means that we add 1 here and, well, B plus D plus 1 is equal to E. Now what's E is the problem. If we solve E, we solve the problem, right? And then, so what's E? So essentially E can be two choices. E is either, so case 1 is that E is equal to 1. And case 2 is that E is equal to 2. So case 1, E is equal to 1. When does that happen? That happens when B plus D plus 1 is equal to 1. Then if this is equal to 1, then A plus C is equal to 11, right? So we put 11 here. So the answer is 1, 1, 1, 1. Okay, so that kind of looks great. So let's just see if this is true. Well, B plus D is 0, meaning B and D are both equal to 0. That's okay because B and D are the digits in the middle of the palindrome. So that doesn't really affect the 3-digit property. So we have A, 0, A, and C, 0, C, right? And then their sum is equal to 1, 1, 1, 1. So that's actually one case. Okay, so, well, we want the largest 4-digit palindrome. So maybe this is a candidate. Maybe 1, 1, 1, 1 is a candidate. So let's just circle it. Potential candidate number 1. Now let's move on to number 2. Case number 2 is equal to 2. How does that work? That works when B plus D plus 1 is equal to 11. So when B plus D plus 1 is equal to 11, then essentially B plus D is equal to 10. And that's actually fine because, well, B and D are the middle digits. So as long as they're non-negative, it doesn't really matter. So we have A, B, A, and C, D, C. Their sum is, well, so 1, and then this is 2 because E is 2 in this case. So their sum is 1, 2, 2, 1. Does this work? Well, A plus C is 11, right? So we have 1 here. So actually, yeah, so essentially, essentially B plus D plus 1 is actually 12 and B plus D is 11 because B plus D plus 1 has to be equal to either E or 10 plus E. So in this case, B plus D plus 1 is 12. So B plus D is 11. Now A plus C is going to be, well, A plus C is supposedly 11. So why is it 12 here? So does that work? It does because B plus D plus 1 is 12, right? So that's larger than 10. So we add 1 here. So A plus C is 11, and 11 plus 1 is 12. That works. So that's actually just candidate number 2. Now, I don't think we have any other candidates. So which one works here? Well, obviously, this option is the answer because it's the larger palindrome. So the answer is 1,221. So thanks for watching. Bye.